Hi, here's the fourth video. This one is more about the definition of probability and how we find probabilities. The probability of an event is some measure about the likelihood that event will occur. So yeah, let's switch to this color. So how likely that event will occur. Um, when we looked at it in 223, if that's the way you took the class, what we looked at probability as a relative frequency definition. So in order to find out the probability event A occurs, you just run an experiment n times, and then you count the number of times A occurs, which we call NA, and then we take that as a proportion. So number of times A has occurred over number of times you run the experiment. So the probability that A occurs is really then just the limit, if you could do this infinite many times, that the NA occurs over N. And of course, provided that limit exists, and also this is more of a simulation or experimental definition of probability. So I thought I would give you an example with Pass the Pigs. Oh, I guess maybe I have a picture. Well, there. So if you've never played, I have a website here that I thought would help us see. Here's Pass the Pigs. So it's really, you have two pigs. I think I'm going to bring them to class, a set for everybody. And you roll them and you get different combinations. It's like rolling dice, but you're rolling pigs. So for example, I roll them. This guy's standing up and this guy's on his side. I think they call this a sider or something, and this is called a trotter. And you get different points for different combinations. Let me go ahead and roll them again. Okay, that's called a razorback when he's on his back. And then I don't know, one of them, I don't know what, the one with the, when he has a little dot, one's like a cider, or I don't know again, the difference with the dot and non-dot, so I'll have to be more clear with the directions. But the question I had written here, let's go back to what's the probability of obtaining a snouter? And a snouter is when he lands like that on his nose. In order to do that, since you probably have never played a lot with these pigs, is you just do the experiment over and over and over, and you would count how many successes over how many tries. So let's roll again. Okay, so this is bad. This is a pig out. But basically, we have 6 rolls now. There's 8 rolls. There's our first snouter. So, well, I don't know how many rolls we have, 8 or 10, but we would say right now we've only seen this snouter once out of the 10 rolls. So a 10th probability. And so, there again, there's 12, I think. 13. We still don't see it. Still don't see it. It's like 16, 18, 20, 22, 24, 26, 28. Oh, there's a snouter again. So right now we see 2 out of 30, so we'd say the proportion of the time it happens is 1 out of 15. But that's the idea of relative frequency definition. Let me go back here again. Let's go down a little bit. However we define probability, there's axioms guiding or governing the way probability can be used. Axioms are like just truths about a field. Like these are the axioms, the given truths, things that must hold true. We've already defined sample space. When you run an event, there's a sample space, and we're going to let A and B be events. These things must always be true for any way you define probability. The probability of the sample space is 1. If everything that could happen is in your sample space, then the sample space has to occur when you run an experiment. The probability of event A or B occurring has to be between 0 and 1. It can't be negative. It can't be more than 1. We say if 2 events are mutually exclusive, remember that means they don't intersect, then the probability A or B, their union, is just the sum of the 2. Because if you think about it, let me draw a picture here. Well, that's not really what I wanted, this pen. here's event A, and here's event B. And if they're mutually exclusive, then to find the probability of A happening or B happening, I would just add up their probabilities. And so this is saying if you had infinitely many events, then the probability of A or B or C or D, or I'm just unioning a bunch of events, it would just be the sum of the probabilities. So I'll actually stop this one now.